So our topic today is the transformer. I'm sure you've seen a transformer, an electric transformer before around your house. So this is our topic today, the transformer. Now, what is a transformer? We define a transformer as is an electrical device is an electrical device that is used to change an EMF. And remember, an EMF is also called electromotive force. So define a transformer as that electrical device used to change the EMF. Used to change an EMF. You see, now there are two types of transformer. There are two types of transformer. Number one, we have the step-up transformer. And then number two, we have the step-down transformer. So we define a transformer as an electrical device that is used to change the EMF, that is the voltage supplied to it. So we have two types of transformer. We have a step-up transformer and step-down transformer. Now, first of all, what is a step-up transformer? A step-up transformer, number one, is the transformer used to increase the EMF supplied to it. So we define the step-up transformer as that transformer is used to increase the EMF supplied to it. You see. While the step-down transformer is the transformer used to reduce the EMF supplied to it. You see. So if you have a transformer where if a transformer is used to increase the EMF, we say it's a step-up transformer. If a transformer is used to decrease an EMF, we say it's a step-down transformer. Now, what is a transformer made of? What are the component parts of the transformer? Structure of a simple transformer. So let's see. Structure of a simple transformer. So it has something like this. It has an iron core this way, and it's got two arms, like you can see here. Then you have a coil wound around it this way. So here we have terminal to terminal, and then we have another one here. It's wound in the opposite direction. You see? Then this one, this is the terminal. These are the terminals. And then this one, this coil here is connected to other devices, other electronic components in the circuit. So this is actually an ion. It's a metal. And then we have coils wound around it. Now the coil is wound, the coil in the two arms are wound in opposite direction. You see, while this one is wound in this way, this one is wound in this way. So that when power is applied to this transformer through here, through the phenomenon or process of electromagnetic induction, current or an EMF is also induced in this place, and then current flows into this place. You see? So now, okay, this is an example of a step-down transformer. Okay, first of all, let's have another one here. And then we have another one here. So of course, these ones go to power supply, while this one goes to, like here, to other components. Okay. Now, if you look at these two transformers here, you notice a difference. The difference here is, in this arm here that's connected to the power, and here also connected to the power, we have more turns in the coil. Here, we have more turns here, while we have fewer turns here. Now, in this side, the one that connects to other electronic components, we have fewer turns, and here we have more turns. You see? So now, this arm is called the primary coil. So a transformer has two coils. The first one is called the primary coil. That's the one connected to terminals where power is supplied. Then the other side is called the secondary coil. It is the one into which an EMF is induced, you see, and it supplies power to other electronic components in the circuit. So in the same way, so here is the primary coil. While here is a secondary coil, you see, because it supplies power to other components in the system, in the circuit. While this one is called primary because it is through it that power is supplied to the transformer, you see, before an electromagnetic induction takes place and the current is induced into this place. Now, like I said, the coils in the primary, so the primary and secondary coils are wound in opposite direction. Because if you don't wind it in opposite direction, there is no way an EMF can be induced in the secondary coil. So now we have the two types of transformer we mentioned above. Here is called the step-up transformer, while this one here is called the step-down. You see? Now, why is it called a step-down transformer? Like we're going to be seeing in a little while. When you supply current or power to a transformer, the amount of EMF that will be induced into the secondary coil is dependent on the number of turns in that coil. compared to the number of turns in the primary coil. So as you can see, we have more turns in the primary coil and fewer turns in the secondary coil. And that means the amount of EMF that will be supplied here is going to be more than the amount of current that will be supplied here. Why? Because the amount of EMF that is induced it has a direct correlation with the number of turns. So since the number of turns is smaller than here, then that means the amount of EMF here will be smaller than the amount of EMF here, you see. Now, this one on the other hand, this is called a step-up transformer. Why? Because, as you can see, the number of turns here in the primary coil is not as many as the number of turns in the secondary coil, which means if you supply an amount of power to this place, an EMF here you're going to have more than what was supplied here. Therefore, it is stepping up the current, sorry, the EMF supplied. While this one will be stepping down, you supply a certain amount, then you have a smaller amount here. You see, so step down transformers are used in circuits where you need a smaller amount of EMF or current supplying the electronic component than the EMF or current being supplied from, let's say, the mains. You see, while step-up transformers are used in cases where the amount of current or EMF supplied to, so in circuits where you need more EMF or current to supply the components than you have supplied to from the mains. See. So for a step-up transformer, also in a step-down transformer, the number of coils in the secondary, so the number of turns in the secondary coil is greater than the number of turns in the primary coil. While for a step-up transformer, the number of turns in the primary coil, in a step-down transformer, the number of turns in the primary coil is greater than the number of turns in the secondary coil. While for a step-up transformer, the number of turns in a primary coil is less than the number of turns in a secondary coil, as you can see. So that's very important.